Hello, everyone, and welcome to this second example of Leontief. So we're going to be solving a Leontief question, and I'm going to be using Kramer's method or Kramer's rule to solve this system of linear equation. And remember, if you have a 3 by 3 system, the best way to solve that 3 by 3 system, it's tough to argue against it, but it's by using Kramer's rule. So here we go. Let's do it. So in a country, they produce oil, natural gas, and electricity. To produce 1 unit of oil, we need 0.2 units of natural gas and 0.2 units of electricity. Notice here that we don't need oil to make oil. So when there's only two numbers, this typically means there's a zero that is hidden here. So I added up that information so that we can see where this zero is playing a role in the computation later. Anyways, for the natural gas, 1 unit of natural gas requires 0.2 units of oil, 0.1 units of natural gas, and 0.3 units of electricity. And then to produce 1 unit of electricity, we need 0.1 unit of oil, 0.2 units of natural gas, and 0.1 unit of electricity. So let's compute the production levels of these three sectors. If the country wants to export 450 units of oil, 400 units of natural gas, and 430 units of electricity. So this country is doing well because it does not need any import to satisfy its internal demand. So they produce enough so that they can export. So this is a question where all the demand are going to be positive numbers. I must confess, typically I like these questions where some of those numbers are exports and some of those numbers are imports, just to see if you see the difference between a plus or a minus when you're building up the system. So here we go. So let's look at the variables. It's already written here for me because I'm lazy. So the variables, but for you, make sure you do label the variables correctly and you define them. There's always marks allocated for that process. So I'll be using P0 for the number of units of oil, PG for the number of units of natural gas, and PE for the number of units of electricity that we need to produce for the internal demand, so for the production of these three products, and the export. So now let's set up the equations. So the equations, they always start by putting the variables on the left side, P0, PG, and PE. So P0, it's PO here, but P0 is how much oil do we need to produce to satisfy the internal demands and the external demand or the export in this question. Same thing for PG and PE. And here, just be careful when you're reading these questions. The information provided for one sentence does not become one equation. For example, if we go back to our first bullet point here, so to produce 1 unit of oil, we don't need any oil. So here, just to illustrate that, I'm going to write this as every level. So every unit produced of oil does not require any of the production of the oil sector. So just to see that, I'm going to write 0P0. At some point, of course, it just goes away. But just for now, just to really remember that there's always three numbers to some extent. They're just hidden when they're missing. Anyway, so now the real first number is 0.2 units of natural gas. So for every unit of oil, I need to borrow some of the production of the natural gas. And the way I'm going to compute how much natural gas that I need to produce P0 units of oil, then I'm going to put it in the right spot. So here, if I want to produce P0, I will need to burn 0.2 times P0 units of gas. And then I also need 0.2 units of electricity. So for every unit P0, I need to multiply P0 by 0.2 to compute how much electricity I need. And that's why this term is in the third column. And if you want to, I'm going to highlight these coefficients in green. So my first zero here in green in my first in my first sentence is my first coefficient of the first equation. The 0.2 in darker green here is the first coefficient of the second equation. And then the last 0.2 in darker green is the first coefficient of the last equation or the third equation. And then you just rinse and repeat. So the same idea now. So for 1 unit of natural gas, I need 0.2 units of oil. So this means that if I want to produce PG units of natural gas, I need to multiply this by 0.2 to get how much oil I need to use in the production level of natural gas. Then the natural gas, it's actually using itself. So we also need 0.1 unit of natural gas to produce 1 unit of natural gas. So for every PG, I need to multiply PG by 0.1 to compute how much I need from the production level, the total production level of natural gas. And then finally, I need also some electricity here. So I need to borrow some of that electricity from the production level of the electricity. So you get 0.3 PG. So if you want to produce PG by multiplying it by 0.3, you know how much electricity you need. Now I'm going to highlight these numbers. Let's say in orange. Okay, so the first number here, 0.2, is my second coefficient in my first equation. The 0.1 in darker orange is the second coefficient in my second equation, and the 0.3 in darker orange is the second coefficient in the third equation. And then again, so for the last sentence, so to produce 1 unit of electricity, how much oil do I need? I need 0.1 times PE. So this is how much oil I need to produce PE units of electricity. I also need 0.2 units of natural gas. So for every unit PE, I need to multiply it by 0.2 to figure out how much electricity I'm going to burn, and then how much gas I'm going to burn, and if I want to figure out how much electricity I'm burning. So again, sometimes I might not say the right sector. Look at what I'm writing down, not what I'm saying, except when I'm making mistakes when I'm writing down, but I'll try to fix those as I go. Anyway, so how much electricity does electricity require? So it's 0.1. So if I want to produce PE units of electricity, by multiplying that PE by 0.1, I can figure out how much I need to borrow from the electricity sector. And then for the demand, so here everything, we're exporting everything. So in this question, all those demand numbers are going to be positive. So in my production level of oil, I need to produce 450 to export. In my production level of gas, I need to produce those 400 units of natural gas to export. And then I need to produce those 430 units of electricity to export. So just put the right numbers in the right spot. Again here, because we're exporting everything, everything is positive. So that's my system of equation, but big fat warning, that system of linear equation is not in standard form. So what I mean by this is that the variables are not all on the left side. Some are on the left side, like the P0, PGP from the definition. These are variables on the left. They're not just labeled, but the constant, I think the best way to really explain this is that the constants, when you look at the constants, they're not alone on the right side. So we want variable equal, like added up together up to coefficient that adds up to a constant. So this is not in standard form. So got excited there. So let me just finish my remark. Worst YouTuber out there, really. Huh? So not standard form. So I need to rewrite this to really see what is my system. If I want to use any tools, Gauss-Jordan or Kramer's rule, I cannot leave that system of equation like this. Again, here, I just realized I forgot to label my to highlight my coefficients. I'm really obsessed with that. So I really want you to see that in the third sentence, the first 0.1 in blue is the first coefficient, is the third coefficient in the first equation. The 0.2 in darker blue is the third coefficient in the second equation, and the 0.1 in darker blue is the third coefficient in the last equation. Okay, so make sure you see this correctly. Okay, so make sure that you, like, to some extent, again, I don't like to say it like that, but it's almost as if you are building a matrix that you transpose when you're building the system. It's not really just that, but anyways, just make sure you put these numbers in the right spot. If not, you will suffer, okay, when you're going to compute shit. All right, so now I want this in standard form. So I'm going to bring everything on the left side. So here, my P0 that is already on the left side stays there as P0. So I'm just, right now, the only thing I'm doing essentially is I'm shipping all those variables. They're all going on the left, you know, like to meet their maker. Okay, so which is literally that and that. So, well, anyways, so here I'm moving everything on the left side. So just grouping all the variables. So for the first equation, there's the P0 already on the left. I'm not going to write, oh, okay, I am. So minus 0 P0 plus 0.2, not plus, man, I'm not listening to my own stupid advice. So minus 0.2 PG minus 0.1 PE, and now I'm leaving the constant on the right. So now that's more like it. And then same thing. So since I want to keep the order, I'm going to write the minus 0.2 PO first, plus PG, the PG which was already on the left side here, minus 0.1 PG, and minus 0.2 PE equal to the constant, which is 400. And then again, okay, so again, I'm starting with P0, so minus 2 P0 now on the left, minus 0.3 PG now on the left, plus PE that was already on the left, minus 0.1 PE, and this will be equal to 430. So the only thing here, I'm doing it in 2 steps. If you can do it in 1 step, of course, do it. But the last thing I'm going to do is just bring those variables together. So what I mean by this is that I just want 1 P0 here. I only want 1 PG and 1 PE. So when you merge everything, you just get P0 on the first equation. So P0 minus 0.2 PG minus 0.1 PE equal to 450 minus, so for the second equation, minus 0.2 PO. So we're starting with minus 0.2 PO. And now for the second part, so PG is like 1 PG minus 0.1 PG. So this will be plus 0.9 PG, and then minus 0.1 PE equal to 400. And then finally, again, starting with minus 0.2 P0 minus 0.3 PG, and then the 1 PE minus 0.1 PE will be plus 0.9 PE equal to 430. Here, notice that all the variables on the diagonal, and this will always be true, are always, the coefficient are always going to be positive. And then the coefficients everywhere else, the coefficients are going to be negative. So here I see minus, minus, minus. Could be zeros also, but when I say negative, it's positive. 0 or negative, same thing for positive. So this is one way to sometimes catch, a little mini mistake, because one little mini mistake will poison everything. So now that my system is finally, so just to make sure when you're reading this, so not in standard form, we're talking about that system right here, okay? The one below now is in standard form. I can now find the augmented matrix. So if I want to do whatever bullshit I want to apply here, so 1 minus 0.2 minus 0.1. So minus 0.2, 0.9 minus 0.1, and minus 0.2 minus 0.3, and 0.9. Again, notice that on the diagonal we have positive, and everywhere else it's negative. And then this is augmented by the domain vector. So the domain, which are all positive here, 450, 400, and 430. And I've decided to call the coefficient matrix for my future computation A and the augmented part B. And this is your augmented matrix. You can apply Gauss-Jordan if you want to. If you read the theory, this is what I call I minus C augmented by D. But I'm going to just go back to standard notation. So now, because I'm a crook, I already have all my matrices ready for Cramer's rule, except for the newer matrix. So the first thing you do is you compute the determinant of A, your coefficient matrix, and please verify that this is going to give you exactly 0.682. Now I'm going to replace the first column. I'm using Cramer's rule here. I'm going to replace the first column by the domain vector. So the domain vector being 450, hello, stupid iPad. So 450, 400, and 430. And please verify, this is a good exercise. This is exactly the level of difficulty that you will face on a test. So here, if you do this computation, you will get exactly, I'm not rounding here, you'll get exactly 477.4. So this will be the determinant of A0. A0 is for the A oil, replacing the first column by the domain vector. Now, if you construct AG, so the matrix A, where you replace the second second column by the domain vector. So here the 400, and so here, since I already have it, I'll just go boom. Okay, so just replacing in the second column, and just make sure that you get exactly 545.6. And then again, so if you construct AE, it could be A1, A2, A3 here. Notation is not too important here as long as you have these three matrices constructed correctly. So now for the last matrix, you replace the column by the third column by boom, okay, the domain vector. And please, my friends, make sure that you know how to get exactly 613.8. Exactly, I'm not rounding here. Okay, so good exercise. Again, this is exactly what you could get on a test. So how do you compute the final answer? So you're just taking those ratios. So for P0, it's going to be 400. So 477.4 divided by 0.682, and verify that this will give you a clean. So this computation here will give you a nice clean, and this is very typical on exams. These numbers, they work very well, and I'm not rounding here. I'm getting exactly 700. So same thing for the production level of gas. So you're going to get 545.6 divided by 0.682. And please verify that this computation is exactly 800, not rounding any shit here. This is pure. And then finally, for the last computation, 613.8 divided by 0.682, constructing the right ratios, and verify that this ratio is exactly 900. So here we go. Perfect question. Perfect application of linear algebra to business. Leontiev forever. Anyways, for that section, that's it. That's all. Bye-bye.